Differentiability theorem. Every differentiable function is continuous, but reverse may or may not be true. Here we can say converse may or may not be true. Now, to prove differentiability, we prove left hand derivative L f dash C and right hand derivative R f dash C to be equal, where C is a point where we have to check the differentiability. Left hand derivative is given by limit h tends to 0 fc minus h minus fc divided by minus h, and right hand derivative is given by r f dash c equal to limit h tends to 0 fc plus h minus fc divided by h. Let's understand this concept by using some examples. First question, show that fx equal to modulus x is not differentiable at x equal to 0. First we'll find left hand derivative. So L f dash c is defined by limit h tends to 0 f c minus h minus fc divided by minus h. Here c equal to 0. So we have to put in place of x minus h. So L f dash c equals limit h tends to 0, and when we put minus h here, modulus minus h minus c is 0, it means it is 0 divided by minus h, which will give limit h tends to 0, h upon minus h, that will give minus 1. Now consider right hand derivative r f dash c, that is given by limit h tends to 0 f c plus h minus fc divided by h. Here c equal to 0, we have to put h in place of x. So we get limit h tends to 0 modulus h minus 0 divided by h. That will give us, since left hand derivative is minus 1 and right hand derivative is plus 1, so both are not equal. Hence, function is not differentiable at x equal to 0. Left hand derivative L f dash 0 does not equal to right hand derivative or f dash 0. So function is not differentiable. Now consider second question. Show that function fx is not differentiable at x equal to 2, where fx is given by x minus 1 for x less than 2 and 2x minus 3 for x greater than or equal to 2. Left hand derivative L f dash c. Here c is 2. So it will be limit h tends to 0 f 2 minus h minus, sorry, 2 minus h minus f2 divided by minus h. So in place of x, we have to write 2 minus h. So it will become limit h tends to 0. Here we write 2 minus h minus 1 minus f2, that is 2 minus 1 divided by minus h. So here 2 minus 1 is 1 and this 2 minus 1 is 1. Here there is minus sign in between. So it will give 1 because minus h divided by minus h, that will give 1. Now consider a right hand derivative r f dash 2, that is limit h tends to 0 f 2 plus h minus f2 divided by h. This time we have to consider this function. So it will become limit h tends to 0, and in place of x we are going to put 2 plus h. So twice of 2 plus h minus 3 minus, it will become 4 minus 3 whole divided by h. We simplify. So limit h tends to 0, and this will become 4 4 plus 2h minus 3. So 4 plus 2h minus 3 minus 1 divided by h. That will give 2. So left hand derivative is giving 1 and the right hand derivative is giving 2. Since they are not equal, so function is not differentiable. Now consider next question. Show that the function fx given by x square sine 1 upon x when x does not equal to 0 and it is 0 when x equal to 0 is differentiable at x equal to 0. Let's see how. Solution: L f dash 0 is limit h tends to 0, and in place of x we have to write minus h. So minus h square times sine 1 upon minus h minus. Here, when we put directly 0, so it will be 0 divided by minus h. We simplify it. So limit h tends to 0, it will be h square, and this will give sine minus theta gives minus sine theta. So minus sine 1 upon h whole divided by h. So this h will cancel out, and here this minus sign will also cancel out. So we will get limit h tends to 0 sine 1 upon h, and this h can be written as 1 upon h, which will give 1. Now consider right hand derivative r f dash 0. So that will be equal to limit h tends to 0, and in place of x we have to write h this time. So it will become h square sine 1 upon h, and then if we put 0, so second term will become 0 divided by h. Again, we will get same thing. Limit h tends to 0, and it will become sine 1 upon h divided by 1 upon h. That will be 1. Since left hand derivative and right hand derivative both are equal, hence function is differentiable at x equal to 0. Now consider next question. Show that fx equal to x square is differentiable at x equal to 1, and also find f dash 1. So left hand derivative equal to limit h tends to 0 f 1 minus h minus f1 divided by minus h. That will be equal to limit h tends to 0 f1 minus h, that is 1 minus h whole square minus 1 divided by minus h, the open bracket, limit h tends to 0, this will become 1 plus h square minus 2h minus 1 divided by minus h. So 1 will cancel out, and here if we divide it, so this will become 2 minus h. When we put h equal to 0, we get 2. Now we consider right hand derivative r f dash 1, that is limit h tends to 0 f 1 plus h minus f1 divided by h values. So it will become limit h tends to 0 1 plus h whole square minus 1 divided by h. 1 plus h square plus 2h minus 1 divided by h, which will give 2. Again, since left hand derivative and right hand derivative are equal, so this is differentiable, and f dash 1 will be equal to left hand derivative or right hand derivative. So we can say f dash 1 is equal. Consider next question. For what value of a and b the function is differentiable at x equal to 0? Since function is differentiable, so it must be continuous. So we can say left hand limit must be equal to right hand limit. That is limit x tends to c minus, and then function will be x square must be equal to limit x tends to c plus, and then function will be ax plus b. So that will give c square equal to ac plus b. Suppose this is equation for 1. Now we consider left hand derivative and a right hand derivative. So L f dash c equal to limit h tends to 0 f c plus h minus fc divided by minus h. Here it will be minus h fc minus h minus fc divided by minus h. We put the value limit h tends to 0, and here we are considering left hand limit. It means we have to write this. So it will be c minus h square minus c square divided by minus h. We simplify it. So it will give limit h tends to 0, c square plus h square minus 2ch minus c square divided by minus h. From where we get 2c. Now we consider a right hand derivative r f dash c. That would be equal to limit h tends to 0 f c plus h minus fc divided by h with values. So it will be equal to limit h tends to 0 c plus h. This time we have to consider this function. So it will become ac plus ah plus b minus fc, that is ac minus b divided by h. Now ac will cancel out, b will cancel out, and we will get a. So it will be a. So what we have got? We have got relations c square equal to ac plus b, and when we equate left hand derivative to right hand derivative, we get a equal to 2c. So we have got the value of a, and now we have to find out the value of b. So we put here 2c. So what do we get? It will become c square equal to 2c square plus b. So b will be equal to this 2c square will be shifted to LHS. So it will become minus c square. So b equal to minus c square and a equal to 2c, which is our answer. Thank you for watching.